is called the White Rose Industrial Physics Academy. Now, the clue's in the name, what it's about. So it starts with White Rose. So this is really meant to be, it's a pooling initiative. And the White Rose, as many of you will know, is York, Sheffield and Leeds will shortly join us. Leeds are an associate partner. Now I spent 25 years in Scotland, and Scotland has the SUPER initiative, which is a pool of physics departments. So this has really influenced my thinking, and it's been a strong guidance in how I want to perceive things. I really think that these regional partnerships are a very good idea and give you strength and unity. So that's why we chose to go that way. Then now it's called the Physics Academy because industrial liaison, I believe, in physics is a problem. I can really see, that's why I said the second sentence, there's a disconnect between academia and industry, which is not so strong, for example, in chemistry. You know, there's a chemical industry, you think of ICI, you think of the T-side companies, you think maybe if you think biology, chemistry, you think of big pharma, but Peter already mentioned it, physics underpins everything, but there's no label, there's no physics industry. And the best example, in fact, the two students who will talk one after me, they said they applied for internships in engineering companies and didn't get anywhere because they're physicists. So the disconnect I referred to is on both sides. The industry needs to recognize that physicists offer valuable skills and expertise and knowledge, and the physicists also need to know where they can go with their skills, in what companies they can apply to. And that's really the sort of disconnect we're trying to resolve by running WRIPA. Now, how are we going to do this? The key element, the key instrument we're using to address this disconnect is industrial projects, and it starts off with the group industrial projects that were initiated by the IOP, whereby we use undergraduates as a tool to engage with companies. And again, coming back to the pooling initiative, White Rose, there's many other pools, as I said, there's SUPER in Scotland, there's SEPNet in the south, there's a Midlands initiative. They tend to operate at the graduate level. They tend to operate at the research level, PhD students. So actually, doing pooling at undergraduate level is something new. And you may not appreciate this, but it's an untapped resource. We thought this is a really new way of trying to bridge this gap that I keep talking about. Okay, so here's what we're going to do. So we want to improve the link between academia and industry, but also prepare students better for a technical career, because there's a lot of feedback that suggests that students are not always as well prepared for life in industry as they could be. Now, is there really a driver, and I've really said this already, that many students don't really know where the opportunities lie, but equally the companies, there were 17 companies out there because they're keen to recruit, and it's difficult for them sometimes to make the link to the right students. Now let me start with the students. So this is my favorite newspaper, and you may not understand. It says, "Müssen jetzt alle studieren?" Does everybody have to have a degree? And this is generic, it's not just about physics, but I want to start here. Now, the point the newspaper makes, a friend of mine says when I gave this talk, "But Thomas, you have in a classical company, you have one chief, you have 10 engineers and 100 workers. Why do we need all these physics degrees?" I said, "Well, my friend, that's maybe 100 years ago. Nowadays, all the 100 workers are replaced by machines, so we need all the physicists and engineers to design and run these machines." But anyway, the point is, do we actually need so many graduates? I think that's a serious question we need to ask ourselves. And I look to Germany because Germany has a higher participation in higher education than the UK. So more than 50% of a year in Germany go to university. So that's a very high percentage. Does it work? Well, unemployment in Germany is 6% for the general populace, 3% for those with a degree. That's a good figure. Salary is also much higher, and it's similar to what Peter told you. So it is worth having a degree. So since it is worth having a degree, we might as well make the most of it. And that's what we're trying to achieve with WRIPA. We're trying to sort of optimize the benefit of education, both for the students and for UK PLC. So now, here's my take on the levers data. And Peter already showed you sort of national. I decided to drill down and look at the York data. This is the Delhi data, and if I don't need to give you the caveat, this is 6 months after degree, this is not taking into account those in higher education. So it's highly skewed data, but it's the best we have. So we might as well look at it. Now, this is just a snapshot. So I looked at 100 of these. This is typically what we get. And you see what people do. BA systems, finance, Eastwood School, I guess that's some training thing. So there's a broad range of things. That's the first message. Physicists do a broad range of things, and they don't necessarily know when they start physics what it is they're going to end up doing. But that's okay, and I think we can be proud of that. As Peter said, physics is the knowledge of everything. So it's not a surprise that they don't, that they do many different things. However, if I look at it in a bit more detail, the things I don't like, stock control at Marks and Spencer's. Do we teach quantum mechanics to stack shelves? I don't think so. Admin support, Packer, bar work. Now, the bar work person, I'm sure Peter will agree, that's the person who just ticks over until I find a decent job. But I still think, with all the caveats in mind, I think we should be able to do better. And that's what we're trying to do with WRIPA. Now, looking at all this, I just picked out what I thought was a technical job and a non-technical job and finance and teaching, and here's my numbers. And what, again, want to highlight, so the guy who does stock control at Marks and Spencer would appear in the non-technical. And I, with all the caveats, I still believe the blue bar, which is a non-technical employment, is too high. And that's what we want to address. And again, we want to address it by bridging the gap between academia and industry. So, how are we going to do it now? Well, don't need more. So, let's look at the employer side, and we have representatives from Dyson here, and James Dyson was in the news not so long ago. Dyson is very keen to recruit, and that's partially why they were here, because they have a strong engineering base in Malmesbury, and they want to recruit more people. They have a lot of interesting jobs to do there, but Sir James Dyson goes into the news and says, we cannot get enough people. So, it's amazing. We have these people who do bar work, and there we have James Dyson say he can't get enough people. There's a disconnect. And again, that's what we're trying to address. Now, last week, Selex in Edinburgh, they ran a recruitment event. And they are so keen to recruit, they paid Andrew and students to go up to Edinburgh to participate in this recruitment event. So, if you hear this, you think, why is any physicist doing bar work or stacking shelves? So, again, I keep making the same point, but it keeps coming up in many different guises. There's a disconnect which we want to address. So, how are we doing this now? So, we're doing, as I said, it's based on group industrial projects. The idea being that students conduct their BSc or MPhil final year project with an industry lead. And this is the picture on the top, is an example of students having gone to Hartlepool Power Station, and that was one of those group industrial projects. So mainly, the project is conducted at the university, but with industrial supervision. And you already heard about it again from Peter. The beauty of WRIPA is that we don't just do that. We also want to run summer internships, and the two Dyson students who will talk at the end, they're doing summer at the company, and then spring, this project also at the company. And we want to do also introduce a year in industry. So we're very keen to cover the range of different projects you may want to do with industry, and also to meet the demands that an industrial partner may have. But there's more than that. The second big tranche of our activity is laboratory development, and I think that to sum it up, we don't just want to run laboratory projects where you measure something, you have a setup, and you work out some constant or so. But the idea is to make people understand that there's no such thing as a correct answer to an experiment. So that we introduce experiments that are open-ended, that you have to design yourself, that are not just on the sheet where you can look up the result and make sure you get the right results, you get the good mark. We need to train you to get to conduct experiments such that you design them yourselves and that you don't know the outcome. Because that's what real life is like. And in fact, for my academic colleagues, you know, if you want to go into research, it's exactly the same. So this idea that an experiment has a well-defined answer and all you're trying to do is get to that answer is a wrong idea. But unfortunately, many of our experiments are designed that way, but we want to bring in a new way of thinking about this topic. So then the third aspect, recruitment fair, well, that's just happened outside. I think that's very successful. And the fourth one, again, I call it, you know, thinking like an entrepreneur, but it's really problem-based thinking. It's to really understand and see where the physics is in real-life objects and how we could maybe improve it. So not just learning about physics, but also thinking how I can take physics to the next step. So I think there's a nice complement of different activities we're trying to put forward, and all hopefully to the benefit of our students. So there's more to it, however. You see, as David kind of said, you know, I'm not just interested in teaching. I do a bit of research by the side. So actually, what makes me tick, what makes me get up in the morning, is to do my research and to be with my students. So why would I want to do the industrial physics thing if it stops me doing my research? The answer is it doesn't. And I bring 3 examples where we show, you know, examples of how our research can also benefit from dealing with these companies. And, you know, for example, Promec we've conducted projects with them for a while, and now we've recently got a TSP project awarded. Dyson has already sponsored research in physics, and you'll hear later how they're also now supporting some of our students. And MM Microwave, same thing, they've just won a KTP, a knowledge transfer partnership with some of my colleagues. So research and teaching goes hand in hand. And I think that's one of the beauties of this, and it's all about building relationships between academics and companies. So there's more to it, even for me. Right, and that brings me to the end. So I think I've made it quite clear, we believe there's a disconnect between academia and industry, and we have identified a number of ways how we can address this. And I think the key point is that, you know, undergraduates are an untapped resource in this respect, and I think both academics and companies and undergraduates will benefit from initiatives like this. And that's where I leave it. Thank you.